Welcome back to the Walnut. Today, in this session, we are going to discuss a very interesting concepts from the topic permutation and combination. So this is conditional arrangement. So most frequently, you will get such a kind of question in your aptitude exams. Question is very simple. How many different ways can arrange the letters from the word walnut? So there are conditions. The first one, that's the normal type of question, number of all arrangements. And the second, a slight improved condition we applied here, number of rearrangements. So only use the additional term re here. And the third condition is vowels together. That means how many different ways can arrange the letters from the word walnut such that all the vowels together. And the fourth one, vowels never together. I will explain the most easiest and quick way to find the answer for these all questions. First, we have to consider the general type of arrangement, that how many different ways we can arrange the letters from the word walnut. So here you just simply observe how many letters here. So there are 6 letters here. Suppose we just consider if we are arranging them in 6 places. So consider 6 places here. So we are considering each place by place. Here we have 6 letters. First we just think about this particular place. How many different ways we can fill any one letter among these 6 letters in this particular place? No doubt there are 6 ways, which means you can fill that place with any one among these 6 letters. So don't forget, one among these 6 letters we fixed here. Rest, how many letters are available for filling the second place? Yeah, only 5 letters. So 5 ways we can fill this particular place. In the similar way, here this place we can fill in 4 ways, this in 3 ways, this in 2 ways, rest only 1 letter here, therefore 1 way. And what's the total number of all the possible ways here? Means this place in 1 way we can fill, and 2 ways for this place, and 3 ways for this place, and so on. So for getting the total number of all the arrangements, what you want to do, you just simply multiply these all values. So there is a direct expression for finding the answer for such a type of arrangement, that is factorial. So this is 6 factorial. So here we can easily conclude the answer for this question is nothing but 6 factorial. Here we don't want to bother too much about the numerical value 6 factorial. Anyway, you can easily find out the value for this one is 720. But here, in this particular lesson, we are considering only the concept. So here, the second one, number of rearrangements. What is the difference between these 2 tasks? This is total number of arrangements, which means including the given order also. But the case of rearrangement, which means you don't want to consider the present arrangement, means which are the other possible types of different arrangements. We know that total 6 factorial arrangements. Out of these 6 factorial, 1 is the already existing one. So you have to subtract that value from 6 factorial. You will get the answer for this question easily. So this is simply 6 factorial minus 1. So that's a simple concept. Got it? Now we are moving to the third concept. Vowels together means how many different ways we can arrange the letters from the word walnut such that all the vowels together. Here, first you have to identify which are the vowels in this given arrangement. Here, the vowels are A and U. These are the 2 vowels in the given set of letters. While we are arranging, means we know that there are 6 factorial or 720 possible arrangements. Out of these 720 arrangements, how many of them contains this condition vowels together? For this particular type of arrangement, I will give the trick directly. Here are 2 steps for this operation. First step, identify these vowels and put those vowels in a single box. A and U. You just put it in a single box. And write rest all the letters here. W here, L here, N here, T here. Whenever we are shuffling these all objects, consider this as a single entity or single object. AU, that is a single box. So now, including this box, how many objects here? 1, 2, 3, 4 and 5. So 5 objects, how many different ways we can arrange 5 objects in a row? Like this way, here we can conclude this is in 5 factorial ways. And in addition to this general arrangement, the case of this box arrangement also we have to consider separately. Inside this box, there are 2 elements, A and U. How many different ways we can arrange those 2 letters inside the box? There are 2 factorial arrangement. I already mentioned the point, that's the basic principle concept of multiplication. So if this event can be done in 1 way, this in 2 ways and so on, the total number of occurrence of all the events together, for that we have to multiply all the values. In the similar way, the general arrangement of these 5 objects, that's in 5 factorial ways, into, so the second possibility, the number of arrangements of these 2 letters in this box, that's in 2 factorial. Hence our answer becomes 5 factorial into 2 factorial. So the answer for this question, 5 factorial into 2 factorial. Got it? Now we are moving to the last condition. Vowels never together. Here you can easily catch it. I will explain 2 different ways for finding the answer for this particular question. Vowels never together. So 2-step type of approach I will explain first. First, what you want to do, here we know that 2 vowels and 4 consonants in this set of letters. You have to arrange the non-conditional group in a row. That's the first step. Non-conditional group in the sense arrange all the consonants in a row. First W, L, N and T. Just observe how many different ways we can arrange these all 4 letters in a row. No doubt that is in 4 factorial ways. In addition to this, that's the very important point. After this arrangement, how many alternate places occurred here? Alternate in the sense, here while we are arranging these places, the given consonant should be act as an insulator because our requirement vowels never together. In the arrangement of 4 consonants, we got 5 alternate places, which means you can fill the given 2 vowels can be filled in any of these 2 places out of the given 5 places. So that's a direct permutation result. There are 5 total places. Out of those 5 total places, only 2 places we have to select for the arrangements of 2 vowels. How many different ways it's possible? That is 5p2. Clear? So first step, we have to arrange all the consonants. There are 4 consonants, hence 4 factorial ways. As per the arrangements of 4 consonants, we will get 5 alternate places. We have only 2 vowels, therefore we are checking how many different ways these 2 vowels can be filled in 5 given places, that is 5p2. So the answer for this question is 4 factorial into 5p2. One more interesting conclusion for this particular question. Here in our question only 2 vowels. So here we got the idea that the number of total arrangements is 6 factorial. So if vowels never together, what is the contradiction of such a statement? Never together. Its contradiction is together. Don't forget, it's only the case of 2 vowels. If the number of vowels is more than 2, this vowels together is not the direct contradiction of not all the vowels together. So here we just consider if we have 3 vowels here. So vowels never together, which means no 2 vowels together. So what is its contradiction? At least 2 vowels together. Got it? Which means the contradiction of vowels together is at least 2 vowels together. In this question, only 2 vowels we have. Therefore, these 2 statements are direct contradicting statements. So for getting that idea, if you need to consider the required number of arrangements, what do you want to do? You just subtract the contradiction from the total number of arrangement. Here the total number of arrangement is 6 factorial. And what is the contradicting condition here? Vowels together. So therefore, for getting that answer, total minus contradiction is 5 factorial into 2 factorial. So you just simply subtract this 5 factorial into 2 factorial from the given total number of arrangements, 6 factorial. No doubt you will get the same answer. These are 2 different ways to find the answer for this particular type of question. Keep these all arrangements tricks in your mind. These are the most frequent arrangement questions that you can expect in your aptitude kind of exam. So the first condition, number of all the possible arrangements. Second condition, rearrangement. Third condition, together. Fourth condition, never together. Hope you got it clearly. Thanks for watching.